This session is a comprehensive deep dive into designing scalable, resilient data layers for multi-tenant applications using Azure Cosmos DB, focusing on balancing tenant isolation, cost efficiency, and operational simplicity. You'll discover the architectural patterns, trade-offs, and innovations that empower modern SaaS platforms to deliver secure, high-performance experiences at scale. Welcome to this AI-generated recap of Design Scalable Data Layers for Multi-Tenant Apps with Azure Cosmos DB. For hands-on demos and more details, be sure to check out the full session video linked below. A fundamental challenge in multi-tenant application design is finding the right balance between tenant isolation and cost per tenant. Imagine the difference between an apartment building and a neighborhood of single-family homes. Shared environments pool resources for cost efficiency but offer less isolation, while dedicated environments maximize isolation at a higher cost due to underutilized resources. In practice, shared environments are cost-effective, but can suffer from noisy neighbor issues, whereas dedicated environments provide strong isolation but require provisioning for peak usage, leading to wasted capacity. The right approach depends on your application's security, compliance, and performance needs. It's important to recognize that multi-tenancy for stateless app hosts and stateful databases presents different challenges. Stateless apps typically isolate tenants at the container or function level, using rate limiting and security policies to prevent resource contention and untrusted code execution. Databases, on the other hand, must protect persistent data at rest and in flight, with tenancy units like database instances, schemas, or tables. Special considerations include encryption, backup segregation, and preventing cross-tenant data leaks. Azure Cosmos DB introduces advanced patterns such as customer-managed keys and shard-level security to address these needs, ensuring both performance and data protection in multi-tenant scenarios. In Azure Cosmos DB, there are two primary patterns for tenant isolation: using a partition key per tenant or provisioning a separate database account per tenant. With the partition key approach, all tenant data resides in a single container, partitioned by tenant ID, often with a hierarchical key structure to support large tenants and efficient data distribution. This model is ideal for scenarios where strong isolation isn't critical and cost efficiency is a priority, as throughput is pooled and shared across tenants. Many Microsoft ISVs use this model for B2C and B2B applications with smaller tenants. Be sure to watch the full session for the complete demo and walkthrough. When strict isolation is required, each tenant can be assigned their own Cosmos DB account and container, partitioned internally by user ID. This model offers robust security and performance isolation, supporting customer-managed encryption keys and eliminating noisy neighbor effects. However, managing thousands of dedicated accounts introduces operational complexity, especially around throughput tuning and resource allocation. To address this, Azure Cosmos DB fleets were introduced, providing a high-level grouping of database accounts to simplify large-scale multi-tenant deployments. Cosmos DB fleets organize tenants into fleet spaces, logical collections of database accounts grouped by similar performance or tenant class. Fleet spaces enable pooled throughput, allowing all accounts within a fleet space to draw from a shared pool of request units. This pooling simplifies capacity planning and cost management, letting tenants burst independently while sharing resources when others are idle. Setting up a fleet space is straightforward. Name it, enable throughput pooling, select regions and limits, and add tenants, all managed through the Azure portal. Throughput pooling is especially powerful in multi-tenant environments where tenant workloads spike at different times. Instead of provisioning for each tenant's peak usage, you provision for typical usage and let the pool absorb bursts. For example, if a tenant usually consumes 1,000 RUs but occasionally spikes to 1,800, the extra demand is covered by the pool, reducing over-provisioning and lowering costs. This approach achieves both strong isolation and cost efficiency, and is now available in preview. Resiliency is a top priority in multi-tenant architectures, and the cell or bulkhead pattern is a proven strategy. Tenants are grouped into cells based on load and environment, such as free trials, non-production, and production. This compartmentalization ensures that if one tenant or cell encounters an issue, it doesn't cascade to others, maintaining overall system health. The approach is inspired by naval ships, where bulkheads contain damage and prevent the entire vessel from sinking. Another critical pattern is the circuit breaker, which protects the system from cascading failures. In a shared ingestion queue, a single unhealthy tenant can block the queue and impact many others, much like a customer holding up a grocery line. The circuit breaker pattern isolates the problematic tenant, failing them fast and redirecting them to a separate queue so healthy tenants continue uninterrupted. Implementing circuit breakers is essential for limiting the blast radius of failures and ensuring smooth service for all tenants. Cosmos DB enhances resiliency with per-partition automatic failover, ensuring that failures are isolated to individual partitions rather than affecting the entire database. This design delivers zero downtime, backed by a 99.999% SLA and supports all consistency levels, including strong consistency with zero data loss. Failovers are fully automated, requiring no manual intervention, and keep distributed deployments continuously available even during failures. In active-active multi-region Cosmos DB deployments, dynamic right region election enables granular failover at the partition level. The distributed failover manager monitors partition health across regions. And if a partition in the primary region becomes unhealthy, only that partition fails over to the secondary region. This minimizes service disruption and maintains high availability with minimal impact on the rest of the database. Dynamic autoscale complements per-partition failover by allowing partitions and regions to scale independently. This granularity matches the precision of automatic failover, improving cost efficiency and resilience for uneven workloads. Only the affected partition scales up in the disaster recovery region, avoiding the double cost of fully sized standby regions and making high availability more affordable and operationally efficient. With dynamic autoscale, disaster recovery regions can be sized independently from active regions. Active regions scale up as load grows, while DR regions scale down when idle, avoiding double costs of fully sized standby regions. When a partition fails over, dynamic autoscale scales up only that partition's resources in DR, maximizing cost efficiency and resiliency. This approach makes high availability and disaster recovery more affordable and operationally efficient. Monitoring thousands of databases after production is challenging. You can't just check each individually. You need powerful fleet-wide monitoring tools. Managing large Cosmos DB fleets requires powerful monitoring tools. Aggregated telemetry views help identify tenants experiencing rate-limiting or performance issues across thousands of databases. These tools enable deep dives into query patterns and partition usage. Revealing inefficiencies and hot partitions, global secondary indexes can further optimize query performance, reducing request unit charges for common queries on large tenants. Monitoring isn't just for site reliability engineers. Finance and product managers also need insights into historical cost and usage trends across fleets. Fleet Analytics exports hourly aggregated performance, usage, and cost data to Azure Monitor or storage accounts, enabling rich dashboards and raw data queries. This empowers teams to identify idle containers, optimize resource usage, and proactively manage operational and financial health. Fleet Analytics also enables custom queries across your entire multi-tenant fleet, providing granular visibility into costs and usage. For example, you can quickly find containers costing over $100 a month but storing no data, highlighting idle resources that can be optimized. These insights help finance and product teams improve customer activation, retention, and cost control. In summary, designing scalable data layers for multi-tenant applications with Azure Cosmos DB involves balancing isolation, cost, and operational simplicity. The session covered key patterns such as partition key and account per tenant isolation, throughput pooling, cell and circuit breaker architectures, per partition failover, dynamic autoscale, and advanced monitoring. Thank you.